Here we're going to do the first 4 problems that we did in class today on Thursday, the adding and subtracting fractions from the carousel. Problem 1, we're looking to add 2 fractions. Remember, the important thing for any time that we're doing addition or subtraction for fractions, we have to have a common denominator before we can put them together. Specifically, if it's something that comes up, we need to have the least common denominator. The least means that we're going to get the smallest denominator possible. That's going to end up being the least work for us as well. So here, we can note that our 2 denominators are not the same. One is x plus 1, one is x plus 2. So to get them to be the same, we multiply. Specifically, we want to multiply by whatever one fraction has that the other one is missing. So the fraction on the left here has x plus 1. We multiply by x plus 2 so that it has the same denominator in the end. And whatever you do to the denominator of the problem, you also want to do to the numerator. So if we look, we can see that we have a denominator of x plus 1 times x plus 2, x plus 1 times x plus 2 in each case. And now what we'd like to do is go ahead and figure out, great, so we've got that. What next? Well, we want to take our values. We have 5, which is multiplying times the x plus 2. So it multiplies times the x, and it multiplies times the 2. And we have our denominator. Plus, we have 4 multiplying times the x, and 4 multiplying times the 1 over our denominator. Take a second to note that our denominators are identical, which is good because we wanted to have that common denominator. Once we have our common denominator, we can add up the like terms in the numerator. So 5x and 4x, 10 and 4. 5x and 4x is 9x. 10 and 4 is 14. And if you would like to distribute in the denominator, you can. Either way is perfectly acceptable. X squared plus 3x plus 2. The second question is very similar. The denominators are not the same. However, pay attention to the fact that we have subtraction. For now, that just means we need a common denominator. But later on, it's going to mean that we need to get careful with negatives. So same process as last time. We get our denominator of x plus 2 times x minus 1. We know that's where we're going to end up. That is our common denominator. In between, we need to distribute. 5 times x, 5x. 5 times 2, 10. Over x plus 2 times x minus 1. Minus 6 times x, 6 times negative 1. Over our common denominator. And now, just like in the last problem, we find our like terms, and we look to combine them. 5x minus, paying attention to the fact that we have subtraction this time, 6x. 5 minus 6 is negative 1x. And then 10 minus a negative 6. When you subtract a negative, it turns into a positive. So 10 plus 6 is 16. And again, if you'd like to, you can multiply the denominator to get x squared plus x minus 2. Our third question, we again see that we have addition, which means we have to have a common denominator. Our denominators are not common. The long way to do this problem would be to approach it exactly the same as the other ones and say, well, I'll take the denominator of the first fraction and multiply it times the second, and denominator of the right fraction, and multiply it to the left. And there's nothing wrong with that, but it's going to be so much more work. So instead, what we said that we would do is look at what the denominators already have in common. Here that's x plus 3, and what one denominator has that the other does not. Here the left denominator has x plus 5, but the right one does not. And just make them the same. And this is our least common denominator. So instead of having to multiply by everything that we saw earlier, we just multiply by x plus 5 in the right fraction. So the left fraction, we've seen no change. The right fraction, we distribute. 4x times x, 4x squared. 4x times 5, 20x. All over our common denominator. We can add those up. You can look for like terms in the numerator, put it over your common denominator. We have 4x squared, x to the first power, and just a constant with no x on it at all. So none of those are like terms. They all stay separate. And if you would like to, you can multiply out the denominator, but that is not necessary for the problem. The fourth question, we're looking at something very similar to the last question, but we have to do a small step first. So again, the long way would just be to look at them and say, well, I want to get the same denominator, so I'll multiply by the denominator on one side to the other side. And already, this process here of multiplying, that looks awful. It's going to take a while. We could do it. You're definitely capable. We saw that a couple of units ago, but I want to make this easier. So instead, we want to try to get everything into these factors, like x plus 5. So we have this quadratic here. And we've seen a few times throughout the year that a quadratic can factor. So I want to look at what multiplies to 10 and adds up to 7. So I can think for a little while and figure out, well, if I have 2 and 5, they multiply to 10 and add up to 7. And my other fraction, I haven't done anything to yet. And just like the last question, I have something that both fractions have in common, but then also this x plus 2 that is only on the right fraction. So if I multiply by x plus 2, now the denominators are going to be common. So I have 4 over our common denominator plus 3 times x plus 3 times 2 over our common denominator. And I can combine these together. 4 doesn't combine with the 3x, but it does with the 6. And we have 3x plus 10, the 4 and the 6 together, all over our common denominator. And one more time, if you would like to, you can distribute the denominator, but it is not something that is going to be necessarily required at any point. So x squared plus 7x plus 10. And that is the addition portion of today's practice.